So anomaly detection. First, what is anomaly detection? On a given data set, 99.99% records belong to one case, one class, and 0.01% records belonging to another class. Right? So all are ones, all are zeros maybe. Maybe bunch of records belong to one. That's the anomaly detection. This generally happens in manufacturing industry and financial fraud. So we have taken this fraud detection, the credit card fraud detection data set. This is present in Kaggle, and we have taken that and we are trying to solve the problem. See, if you see this, right, there are 2,84,807 records belonging to fraud case. Sorry, the total transactions, right? 2,84,807 total transactions. Out of them, 492 are fraudulent transactions. Remaining 2,84,315 records are non-fraudulent records. Okay, so these 492 records are 0.7117%, and we have 99.8% records belonging to non-fraud records. Okay, my first question is, when we are creating the data set, to which class we should be taking 0 and to which class we should be taking 1? No, these 2,84,315 records should be 0 or 1?
0.
Yeah, the 492 records belonging to 0 or 1. So Krishna said, this is 0 and these 492 records 1. Is that right? Anybody agrees, disagrees? Guys.
It's because 492 is the output we are looking for. So
yeah. Our focus is to identify the records which are of this kind, which are of this kind, 492 kind, right? And they are rare, right? The problem with the precision recall or the accuracy measure, basically the accuracy measures problem is, even if you put everything as 0, right? We are thinking of putting the flag as 0 for 2,84,315 records. Even if you put 0 for all those records, total data set, you will get 99.8% accuracy. And one more thing, if you put 1 for 2,84,350 records and try to build a model and look at precision recall scores, then also you will get 99.8% precision and 99.8, around 100% precision and recall scores. So to avoid that problem, we need to assign 1 to 492, 0 to these 2,84,315 records. First thing, did you get it? In anomaly detection, first thing is data preparation. So we are talking about that. Did you guys get it? Any questions there?
Sir, I didn't get why we are exchanging the label values.
No, did we exchange anything there?
Means exchange means 0 to 1, 1 to 0.
No, I am not exchanging anything. I am asking you a question. I have that, right? I did not assign any flag here, right? Let me ask you a question. And I am explaining rather than asking a question, right? So I have 99.83% records belonging to one class, not fraudulent transactions. Okay. 0.17% records 0.17, right? 0.17% records belonging to fraud. Okay. Should I assign, what should I assign to? The target variable. I need to prepare the data set, right? What should I assign to these number of these records, and what should I assign to these records? There are 2,84,307 records, 99%. What flag should I be assigning? For 483 records, what flag I should be assigning? That's the question I asked.
Okay.
What flag should I be assigning?
Our objective is to detect the 483 only, right? So better if we assign 1 to 483.
Okay, that's what Krishna also explained. So 0 to these records and 1 to these records. If we assign, right, the question I asked is, the point I am trying to explain is, if I assign 1 here and 0 here, we may get 99 point whatever percentage of precision and recall also. Right, this concept we understood long back, right? In the classification beginning class, I explained, right? This point we already understand, right? So we need to assign like this only. Okay, so that's the point I tried to explain again. That's maybe a bit confusing. Okay, so we have taken the data set and assigned the flags. The first thing we did that, and then we need to understand which features are useful, right? The feature analysis, right? To do that, what we did was, we actually did, this is from Kaggle, somebody else did it, and we actually found that is very interesting, and we actually copy pasted it here. So what the guy did is, for each column, he is trying to understand distribution of 1 records and 0 records. For each column, the guy was trying to understand the distribution of records belonging to 0 and records belonging to 1. If the distributions are overlapping, when I say overlapping, right, like this, the point is that the data cannot actually distinguish these two classes. If it is distinguishing like this, right, the patterns are not overlapping, then they can. Did you guys got the point? Did you guys got the point? See these graphs, right? This is for first column, and how many 0 records are there, how many 1 records are there, and how the distribution is, right? We are trying to understand the dist plot, right? So how many zeros, how many ones we are trying to understand. If they are overlapping, right, that means there is not much difference, or not much difference in the data distribution. So
sir, one question. What is the brown brown area here? There is mentioned, yeah, pink and green are there. Genuine class and fraud class.
Brown is overlapping area.
Oh.
Overlapping area. It is, the green and the pink color mix. It is. It's coming like a brown thing. Got it? If you see here, only red is there. Only it's in a square shape. That's where you see it as, brown. It is overlapping area. That's it. But if you look at this graph, right, you'll understand. See this? Oh, sorry. See this? This is overlapping, right? So overlapping means both columns, both 1 record and 0 records have same distribution. So they may not be able to distinguish the target variable. So the feature is not important. Got it? But the columns which are not overlapping can actually, see this, these are completely overlapping, can actually distinguish the difference. So in that case, we actually took all these columns as not useful. If you look at V28, where is that V28? Here, see this? They're completely overlapped, right? Again, V27 overlapped, right? V15, 13, V15, 13, see this? 13, see this? So we dropped all those columns which are having overlapping distribution patterns, data distribution patterns. This is one way. This is one way of, no, give me 1 second. Give me 1 second, okay? Sorry for that. I got a call. So, that is the feature selection we used. Okay. So, in anomaly detection case, right, you can actually build, regular the random forest kind of a model, and then also do feature selection. We have the article. I'll show you. You guys need to go through it, because if I try to explain everything, right, thinking should happen, because in interviews, right, when you think and find out something, your confidence level will be more. If you have questions, come back, look at the articles and come back. I'll show the articles in our website. Okay, so you can do that also. But here, using statistical data analysis, we actually selected the data set. So data set is ready now, right? We flagged the data with appropriate flags, the target variable. The second thing, we understood data patterns. Based on data patterns, we did feature selection. Now data set is ready. Let us try to understand the algorithm. Okay, so very, very simple algorithm it is. Let us take 60% of genuine records, y is equal to 0, and non-fraud records, so the train set will not have a label as well. So no fraud record, sorry. So 60% of genuine records. What is genuine record? Y is equal to 0, right? We'll take 60% of the genuine records. How many genuine records are there? 2,80,307. Out of which 60% randomly chosen records, we'll take them as train set. No records belonging to 1. No records belonging to 1. This is the anomaly detection algorithm. Train set is considered. It is not, we are not doing 80-20, no, those split we are not doing. We are just taking 60% records of y is equal to 0 and putting them aside. Okay. And then cross validation test set and test set we are preparing. The train set has got only records belonging to y is equal to 0, 60% of them. The cross validation set will have 20% of genuine records and 50% of fraudulent records. What is 50% of fraudulent records? How many fraudulent records are there in the data set? Do you remember?
400 something.
Yeah, 400 something. 482. 482. Out of those 482 records, 241 records we'll take and mix them with 20% of the genuine records. Out of 2,80,307, 84,307, 60% were taken as train set. 20% was taken and mixed them with 241 records of the fraud records, and test set we prepared like remaining 20%, right? We have 2,84,307 records, 60% train, 20% cross validation, 20% test. 100% of 2,84,307 are covered, right? Rest of the 241 records are mixed with the test set. That's how we prepared. So let me draw this and keep that aside. So we have a big data set. It is a very simple algorithm. Okay, very simple algorithm, but very powerful. Y, x1, x2, and so on, xn, right? And there are non-fraud records. There are fraud records. So first what we did was, we actually separated these two, fraud records and non-fraud records. Out of this, right, we took 60% and kept that as train set. Right, and then we took 20% cross validation, and here we split it into 50%, and this 50% we mixed it with the cross validation. Now cross validation has got 20% zero records and 241 records belonging to one. And then we took rest of the 20% into test. 20% zero records, 20% of the non-fraud records, 20% of zero class records. Okay, 50% we mixed it with, right, 241 records belonging to one. This is how we constructed the data set. Okay, then produce anomaly. No, the procedure for anomaly detection. Find a model, right? Find the model P of X on train set. The probability of each record on train set we need to find. That's the model. On cross validation and test, predict, right, with an epsilon. We will find the epsilon on the train set, use that epsilon and try to test it on test set and validation set. If it is not working well, right, then we will, maybe that's like additional thing. Let me correct myself. Okay, we will find the probabilities and keep them aside. The intention here is not to find the probability. Intention is to find the means and standard deviations. I'll explain what that is. On train set finding probabilities, the intention is to find means and standard deviations. Okay, and then on the train set we'll find different probabilities, right? Those probabilities we call them as epsilons. We'll try to use those epsilons and see where exactly the cross validation and test sets are working. And once after finding the epsilon, right, that's what is that's what the probability. So let me explain that here. So what we will do is, for each record, right, let me take another color. What the heck, man? So let me take another color, and here for each record, the record 1 will calculate probability, right? P of X superscript 1, P of X superscript 2, P of X superscript 3, like that we will find for K, right? Maybe N, maybe R number of records, right? P of X R. How do you find this probability? We will use normal distribution probability density function. PDF of normal distribution is 1 by 2 sigma. Some formula is there. Let me look at that. I forgot the formula. I think somewhere here to be mentioned. Estimate Gaussian. Yeah, use the formula. Let me look at that. So this is the formula: 1 by sigma 2 pi into e to the power of minus x minus mu square by 2 sigma square. What is mu and sigma here? Mu is the standard mean and sigma is the standard deviation, right? So we need to calculate probabilities of each row there, right, using the PDF function of normal distribution. Okay, so to calculate PDF of normal distribution, so the probability of each record P of x1, right, what we need to do is we need to calculate P of x1 into P of x2 into and so on P of xn. Okay, For each column, we will use normal distributions probability density function. This formula we will use. What we need to calculate here? Sigma, mu, right? So what is sigma and what is mu? For the first record, it is sigma 1 and mu 1 we need to calculate. To calculate probability, we need to calculate sigma and mu 1. So the second record, sigma 2 and mu 2 first to calculate the second probability. Like that, for every record, for every column, we need to calculate sigma n and mu n. Okay. Once after calculating these, we can calculate p of x1, p of x2, and so on, p of xn. And when you multiply, right, you will get probability of p of first record. But the second record also same thing. Third record also same thing, like that, right? P of x2, p of x3, and so on. No, xr, right? So mu and sigma are same, but x is changing, right? In this formula, the mu and sigma are same, pi is constant, but x is changing. With x changing, right, the probabilities will change. So far, are you all good? Right? Data preparation and calculating probability. Are you all guys good? Any questions? No questions, right?
In test set, we are finding the probability density function value for each and every record.
Train set, we are doing that.
Sir?
Train set, we are doing that. Test set, I'll come to that.
Okay.
Test set will come. Right? When we calculated, right, generally these probabilities should be in a range, right? This is not there in the algorithm, but I'm just trying to explain that. When you calculated probabilities for each record in train set, right, these are all belonging to 0. So if they are between, maybe 0.3 to 1 range, right, these probabilities are between 0.3 to 2 to 1, then what we can say, the fraud records range is going to be between 0 and 0.2, right? 0.9919, right? We'll say 0.2, right? 0 and 0.2, the fraudulent records, the one class records range is going to be, probability range is going to be this range, right? That is one point, but we will not consider this. Keep this aside, right? Put this in your mind and keep it aside. So we calculate probabilities here, right? Using the means and standard deviations, right, calculated on the train set, we will calculate probabilities for cross validation set and test set also. Okay. Let me take that. On the cross validation set, we'll calculate probability, right? And on the test set also, we'll calculate probability. Here, right, while calculating probability on the test set and cross validation set, I am using the sigmas and mu's calculated on the train set. Is that a right approach? Did you guys get my statement?
No, sir.
While calculating probabilities for the test set and cross validation set, I am using mu's and sigmas calculated on the train set. Is that a right statement, right approach?
Population sample mean can be used for population, but within the population, if we have divided the data into training set and test set, I don't think we can use one data set to another data set.
No, here I don't know.
In the same data set, maybe you can use it. You can use the sigma and mu.
Maybe we can, but is that a right approach? If it is not a right approach, is there any other approach? Our goal is to calculate probabilities for each row, right? on the train set and class validation set and test set, all rows we need to calculate probabilities. But while calculating probabilities on the train set, I calculated the the standard deviation and mean, and calculate probability. That's fine. But on the cross validation and test set, I'm using the same standard deviation and mean. Is that the right approach?
We can use it, sir, because training data set is 80% and test data set is 20%. 80% data set is almost similar to the almost close to the population mean.
Yeah, 60% here, right?
60%.
Right. So you got it, right? The point, Bala got it, but rest of the people, right? We have to use the standard deviation and mean from, which is derived from train set only, because that has got huge volume of data. Anyway, the fraud records are very less, right? There is no possibility that we can get appropriate or a mean and standard deviation which represents the data set's mean and population, right? Mean and standard deviation, right? So it is about best approximation. When you take 60% of the data and trying to calculate mean and standard deviation, it's going to be the best approximation of mean and standard deviation. That is the learning. From training set, that is the learning we are doing on an anomaly detection. The means and standard deviations are the learning from the train set we are actually trying to get. Got it? Got it?
Yes, sir.
Point is valid, right?
Yes, sir.
So why am I reiterating and stressing it here is, you need to remember this point. This is universally accepted, and in many places you need to, if you have to make a decision, right, this idea is useful. In many places while working on projects, this idea is very useful. Okay, so we calculated the probabilities for the cross validation and test record also, and then what we will do is, all the probabilities we calculated on the train set, we'll take them as epsilons, right? The probabilities are going to be, right, for every record there will be probability, right? So from 0 to 1 we'll take maybe 1000 numbers between 0 and 1, and then try to take the cross validation set and try to find a threshold, right? At what threshold that the records are being distinguished, right? All the probabilities, here for the 20% records you have got probabilities, for the 241 records you have got probabilities, right? And you take 0.001 as one probability and see if 241 records are less than that and the 20% records are greater than this, greater than or equal to this, or maybe this is less, the 20% records are less, and these 241 records are greater than or equal to 0.001, right? What is that? This is actually prediction, right? If it is actually this threshold is deciding or dividing the data into two parts, that means that's the prediction. If you put that in the prediction, right, it's going to give true and false. That's it. Got it? We have understood this in the initial classes, right? Got it? Initial class of classification. How do you predict? How the logistic regression is predicting? Taking the probability, right, 1 by 1 plus e power minus g we consider as probability, and greater than or equal to 0.5 it is predicting as 1. That means true. If it is less than, it is giving false. That means 0, right? Instead of 0.05, we are trying to find the threshold by taking the cross validation set and playing with the different thresholds. We'll take one number, check it, second number we'll check it, third number we'll check it, fourth number, fifth number, like that we'll check where exactly it is able to distinguish data perfectly, the target variable perfectly. We take that threshold as the threshold for the model, and using that threshold we'll test it on test set. If it is working on both, right, then that is the threshold we need to use. In production also, you take the record, you take this mean and standard deviation, calculate the probability. If it is less than this threshold, we say the negative record, greater than we say the positive record. Got it? That's the algorithm. Got it?
Yes, sir.
Any questions? Good. So that's the algorithm. That's the anomaly detection algorithm. You know, the Gaussian based anomaly detection algorithm, we call it as Gaussian normal distribution. The probability density function, we call it as Gaussian normal distribution. Generally, these individual columns probabilities will work, but there is a concept called as multiple normal distribution, right? Multiple normal distribution. Multiple normal distribution means calculating normal distribution for all columns at once. Here we calculate individual column probabilities and multiply, right? Instead of that, you can calculate probability for all columns at once. That also works, but this generally works. And there is a problem with this calculation. When you try to do multiplication of probabilities, right? There is a danger of making this whole multiplication close to zero. Do you guys agree? The whole multiplication may come close to zero. Do you guys agree?
Yes, sir.
Right? Each probability is like 0.01, 0.001, 0.000. Like if you multiply these two numbers, it will become 0.0001. Right? Like that, ultimately, after multiplying all these, you may get a number which is close to zero. All probabilities you may get zero. Right? In that case, threshold becomes like, you will not be able to find a threshold. To avoid that problem, what we will do is apply log transformation to these. Right? When you apply log transformation, what happens? Log xy is equal to log x plus log y, right? So it becomes like log of probability x1 plus log of probability x2 plus and so on, log of probability xn. Each time you calculate probability, you put it into logarithmic function and then sum it up so that you get some value there. That the probabilities are evident. This concept is also used in many places in NLP. Okay, when you calculate probabilities and trying to multiply, you have to multiply, right? The ultimate probabilities will become zero. The ultimate probability will become zero. To avoid that, you apply log transformation and take. For all rows, you apply log transformation, so there is no harm in applying log. Right? Got it? So that is anomaly detection algorithm and how you find out probabilities. Once after finding probabilities, you need to play with the threshold. So you guys got it, right? Then I'll go into the code and show you how exactly we have done it. Any questions? This algorithm is explained by Andrew Ng in his course, but we implemented it. We implemented it and showed the solution here. Okay. So here, this is the method which actually is trying to find threshold. Select threshold by CV anomaly detection. We passed the probabilities, different probabilities for the records, and we passed Y value, and then we are trying to take epsilon, right? All the unique probabilities from the probabilities we have taken as epsilons, and all the records probabilities will be there, right? So we have taken them as epsilons. For each epsilon, right? But for each probability, we are trying to, take prediction. Probabilities for n number of records less than epsilon gives you either true or false, right? We have Y value, either 0 or 1. You can calculate F1 score, and precision and recall. If F1 score calculated in current iteration for the current epsilon is greater than the best epsilon, best F1 score, we are keeping the best F1 is the current F1 and trying to take the epsilon as the best epsilon. Initially, we'll take the best F1 score as 0, right? You predict some things and try to calculate F1 score. If it is more than, we'll try to take that new F1 as the F1 and then the best epsilon as the new epsilon. In the next iteration, we'll try to calculate probabilities, the predictions, make predictions. Again, calculate F1 score. If it is greater than, we'll keep that as best one and keep the F1 epsilon as best epsilon. After n number of iterations, right, you will find out the best epsilon. So using that epsilon, if you try to predict 86% accuracy. No, not that one. So here, right, F1 score is 82% and precision is 90. Recall is 75%. Now, whatever it is predicting correctly, but the records which are fraudulent, it is not able to predict correctly. So in this particular data set, do we need precision more or recall more? In this particular data set, do we need precision more or recall more? You need to think a little bit on the data set, the business area, and then explain. Do we need precision more or recall more on this particular data set? If we are trying to fine tune the model, which measure you try to focus more?
Precision, sir.
Why?
Precision is true positive by divided by true positive plus false negative. I think the formula.
Yeah, that formula is fine, but anybody agrees? Do we need to focus on precision or recall? Anybody agrees with Bala? You don't even agree or disagree. You are not thinking. You need to think along, right? This course is like that. If you think along, right, no need to study again. You don't need to spend time again. That's the use of live class. Online courses are there, many courses are there, right? So I'll say precision. Sorry, I'll say recall. Recall is more important. Why am I saying recall is more important? Can you guys explain? I said I should be explaining that. That I know, but I am saying recall needs to be more on this particular data set. Why? Because we have, yeah, go
True
ahead.
positive and false negative ratio should be high.
Yeah,
True
Bala, I'll say one thing. If you try to explain in terms of formulas, right?
Yeah.
Even I cannot understand. So interviewer also cannot be able to understand. We need to talk in business terms, business terminology. Then it will be understandable by everybody in the team, either a junior guy or a senior guy or a client. Client doesn't even know what is true positive, true negative, right? So no, you know it, but I'm just trying to, just trying to explain, because I'm going to explain like that. Okay. So here the problem statement is that we need to find out the fraudulent records, right? So there are only 432 records, fraudulent records. So on training, while training, if you are able to find out all fraudulent records present in the training set as fraudulent, even if you say some non-fraud records as fraud, that is fine. Even if you say some non-fraud records as fraud, that is fine. But if you find all fraudulent records as fraudulent while training, there is a probability, there is a possibility that in production also, you will be able to correctly identify the fraudulent records. Are you getting the essence? If you are able to predict 95% of the fraudulent records present in your train set, that is true positives, right? And actually positives in your data set are able to be predicted as positive. That means in production also, when a positive record comes, positive records in the sense the fraudulent record comes, you will be able to predict it as positive, fraudulent. The probability is going to be more. If it is 75% probability of finding the existing positive record as positive, on the production, the probability will reduce, right? Got it? What is recall? All the existing records, all the existing positive records, how many of them predicted correctly, right? Right? Guys,
A little bit confused.
okay, let me open the diagram. Yeah, that's why they call it as confusion matrix. Let me open the diagram and try to explain. We still have 15 minutes, right? So let me take the new PPT. That would be better, I think. I don't know which PPT does that. Yeah. So this is the confusion matrix, right? This is, this row actually shows that all positives. Here it shows 702 positive records are there for other data set, right? 702 records, positive records are there. Sorry, not 702. 702 plus 2320, right? Around 3002 records, 3022 records are positive in the data set, right? Out of which 2320 records it predicted correctly. Okay, at a given threshold, it predicted correctly. What is at a given threshold? What is at a given threshold?
Maybe the threshold which we determine using.
Yeah, when I say at a given threshold, right? For each record, there is a number between 0 and 1, right? For each record, there is a number between 0 and 1. We chose maybe 0.5 as the threshold. At that threshold, it actually predicted 2320 records correctly out of 3022 records. 3022, why I am saying? They are the positive records in the data set. Okay. So if that is the rare class, right? On the train set, if you get 0 here and 3222 here, that means the model is working very good. The model is actually trying to find out, the minority class very well, right? If it is doing that well, in real time also, it will be able to do it well. Are you getting it? If you have 0 here and 3220 here, what happens? What that means?
It's predicting 100% correctly.
Yeah, 100% of the existing positive records correctly. Okay. To do that, what we need to do? We need to adjust the threshold, right? From 0.5, maybe I need to adjust the threshold to maybe 0.3 or 0.2. When I adjust the threshold, what happens? All these records, all these negative records may fall into positive, right? Maybe I have that example. I should have that example. Yeah, see this, right? Here, if you see this, at 0.5 threshold, I took 10 records here. At 0.5 threshold, 2 records were predicted wrongly. This record was predicted wrongly and this record was predicted wrongly. They're actually positive records, right? This is positive and this is also positive, right? It is predicted as wrong at a 0.5 threshold. When I changed it to 0.4, right, the model predicted these two also correctly. Okay. Unfortunately, in this particular data set, no negative records fell into the positive case. Okay. But in real time, what happens is when you adjust the threshold, some of the negative records may fall into positive because generally the scenario is that 0.5 is the threshold, right? Less than 0.5 are all going to be negative and more than 0.5 are all going to be positive, right? Right? When you reduce, some of the records between 0.4 and 0.5 may come into the positive case. When it comes, right, then this number increases. In this block, the number increases. That means what? Some of the non-5 records, non-positive records are being predicted as positive while trying to make the model work with the positive records predicted as positive. When you are trying to increase recall, right, precision reduces. When you try to increase recall, precision reduces. In another way, if you want to talk in layman's terminology, when you are trying to predict fraudulent records, more fraudulent records existing in the train set as fraudulent, some of the non-fraudulent records will also come into fraudulent records. Predictions. Am I confusing you guys?
Yeah, it's clear. I got it.
Bala, did you get it?
Little bits.
While talking itself, I am getting confused, right? There is no big deal in you getting confused. But you sit and think, you will get it, right? The essence is there. You sit and think, you'll get it. Last time I'll try to explain one more time. Okay.
Okay, sir.
When you are trying to increase recall, you are trying to predict the existing positive records correctly, existing positive records in the train set correctly. That is the meaning of increasing recall. Existing positive records in the train set correctly.
Okay.
In that effort, you will, to make that, what you do, you adjust the threshold. You may reduce the probability. The threshold probability you may reduce. When you reduce, what happens? Some of the negative records come into positive case as prediction. As prediction, we are all talking in terms of prediction only. Right? Some of the negative records may come into positive case. What is happening there? What are negative records here? Non-fraud records coming into fraud, or the model is predicting non-fraud records as fraud. That's okay. Right? Our main goal is to find out those minute cases. In finding those minute cases, it anyway happens, right? It is, let me give you one example. In a bank, I am, little leisurely guy. I don't work properly. And Bala is a strict guy, right? He works very properly, okay? So he goes by rules only, okay? So if some new record, some guy came in and asked for a loan, we both are working in a bank, and some guy came and asked for a loan. I did not look properly into the documents and gave loan. And Bala always is strict in doing that. And I may give loan to a proper guy and improper guy also. But Bala may give only proper guys, and some proper guys he may reject. Got it? Because he follows by rules, right? Right? In India, government offices it happens, right? They generally don't work properly, but generally some proper guys also he may reject. But what happens ultimately? The model works. His model works well, and bank will always be in profits. With me, right? I may be giving some mischievous guys also the loans because of my lenient behavior. That lenience is the threshold, right? The probability for Bala is a little high. The probability for me is a little low, right? The threshold is a little low. That's where the mistakes are happening more, and the frauds are happening more. Got it?
Got it, sir.
Yeah. So you think now, sit and think. Open this article, try to work with this data and think about it. You will get it. In interviews, they'll ask. If they ask fraud, the credit card fraud detection or anomaly detection, you can eat up for 30 minutes easily. And you can explain your capability also. This particular exercise has got everything. The classification it has got, the anomaly detection it has got, the metrics it has got the confusion matrix, it has got everything. And once you get hold of this particular exercise, you got hold of the total AI, total data science project. Okay. So one more last thing before we leave is that anomaly detection is the article, right? The second article you may have to look into is credit card fraud detection. Here in this article, right? The guy who worked on this is Hanmant Rao. He's in Kuwait now, and he actually worked for 3 months on this project, and he made this available for all of us. Right? I never got time to work on it, and this one he actually worked with the algorithms, right? The normal machine learning algorithms to do anomaly detection. You can use machine learning algorithms also to do anomaly detection, but you need to change the threshold. You need to play with the threshold. Look at both the articles, and Monday, if you have any questions, I'll explain. If not, we'll jump into NLP, the deep learning NLP course from Monday. Okay? Any questions? I'm done for the day.